uh, when you are going to draw the Lewis structure, you have to you have to draw the skeletal structure of that molecule or ions or species. Skeletal structure. Skeletal structure means which atom is bounded with which atom, which mean, right, what is the arrangement of it? Okay, arrangement of it, right? Right. Right. I will give in some example like H2O, CO2, some basic simple molecules and ions, NO2 minus, NO3 minus, NO2 plus, and SO2 and SO3, and CO3 2 minus, SO4 2 minus, SO3 2 minus, ClO4 minus. There are so many simple ions and molecules to draw the Lewis structures. Okay. First of all, you have to draw the skeletal structure of these ions and molecules. Skeletal structures. Okay. To draw the Lewis structure, to draw the skeletal structure, Buddha, you have to identify the central atom of it. Central atom, right? Which atom is act as a central atom? Central atom. Okay. If you know the central atoms of that ions, you can draw the skeletal structure very easily. Okay. Central atom. What are the theories to get the proper or correct central atom? The central atom, it should be central atom, it should be the lowest electronegative atom. Lowest electronegative atom. Okay? Lowest electronegative atom. Electronegative atom. I don't know whether you know the electronegativity. So I will give some small definition and small theory regarding that. The electronegativity means the ability to attract electron from a bond. Ability to attract electrons from a bond. Okay? If the ability is high, the electronegativity of that ion is element is high. Okay? Ability to attract electrons. In the periodic table, from when you are going from left to right through the period, electronegativity is increased. When you are going from top to bottom through the group, electronegativity is decreased. Okay, that's basic theory I have given because I don't know whether you know the theory or not. Okay, what is the theory? From left to right, which means right, lithium, beryllium, boron, carbon, nitrogen, oxygen, right, to the oxygen, to the direction of oxygen, electronegativity will be increased. And sodium, potassium, rubidium, cesium, right? When you are going through the group, the negativity will be decreased. Okay, clear? Clear? Right? Are you clear? Clear? Right? Can you join with me? Right? You can pass the message. You can ask some questions. Right? Are you all clear? Are you all clear? Oh, right? This should be the lowest electronegative atom, right? Okay, lowest electronegative atom, right? And uh, these element cannot be in central atom. What is that? What are them? Hydrogen and fluorine. Except to these atoms and elements, right? Any atoms can be in a central atom as a central atom, but hydrogen and fluorine cannot act as a central atom. Okay, right? Except these atoms, these elements, right? Central atom should be the lowest electronegative atom in the iron and right. But these theories are not important at all, right? May theory it is those theories are very not very important theories, okay? Because you can identify the central atom clearly. Central atom clearly. Okay, I'm sure you will be identified without confusing, without getting trouble. Okay, you will be understand, you will be identify the central atom. Can you tell me that? What is the central atom of H2O? My theory on identify right? Can you tell me that? What is the central atom of H2O? Yes. Others? Others quickly send me the message. Yeah. Yeah. Where others? Right? Yes. Can you tell me that? Right. Now that's finished. Now can you tell me that what is the central atom of carbon dioxide? Okay, now you can identify that clearly because H2O means oxygen, right? That it should be the central atom. What is it? Yeah, yes, carbon. What is the central atom of NO2 minus? Okay, okay, right. I will start right now, right? The theories now. Okay, then you can identify the central atom and you can give underline to the central atom. Okay, then you can take a picture and send me a message. Okay, right. Uh, okay. Uh, okay, now I'm going to give the theories and you have to write the theories like this. Okay, Lewis structure, right? Can you write some details regarding Lewis structures, right? Can you write this note? The Lewis dot diagram is used to, right? This is Lewis dot diagram and Lewis structure, right? The same theory. The Lewis dot diagram is used to illustrate the atomic skeleton. The Lewis dot diagram is used to illustrate the atomic skeleton, nature of the bonding present, which means within bracket, nature of the bonding present within bracket, single, comma, double and triple bond, nature of the bond, single, comma, double and triple bonds. Close the bracket. And the distribution of the valence shell electrons electrons around each atom of the valence shell, electrons around each atoms of the given chemical formula. Given right? That's the theories I have given you. I have discussed that, right? You can get an idea about the double bond, single bond, triple bond, and lone pairs and everything. Okay, and the given chemical formula in Lewis dot dash structure. Lewis dot dash structure mean this is normal Lewis structure. Lewis dot dash structure. Come on. A bonding electron pair is denoted by a short line drawn between the two atoms, right? Bonding electrons denoted by the drawn short line between the two atoms. Okay, that is the Lewis structure. Then move to the second line, right? Next paragraph, right? The following factors need to be considered when drawing Lewis dot diagrams. Okay, Lewis dot diagrams or Lewis structures. Now the Lewis dot diagram, can you write that Lewis diagram, Lewis structures, Lewis diagrams. Right, the following lines, following theories. Okay, the first one is, right? Okay, the first one is identify and place central atom. Identify and place central atom. Identify and place central atom. Under that line, under that step. That is the first step. Under that step, right, you can write this one. Elements H and F are generally not considered as the central atom, since these can form only single bonds, that because of these elements only can form single bonds, therefore they are not placed, they act as a central atom, therefore you cannot place the element as central atom. Why? What is the reason for that? The reason is, right, they cannot form multiple bond, right? Right, for the same paragraph. Atoms which are capable of forming, atoms which are capable of forming multiple bonds, atom which are capable of forming multiple bonds, multiple bonds, multiple bonds are placed as the central atom, are placed as the central atom. Okay, the atoms, which mean the other any atoms can act as central atoms except these atoms. Okay, right? Okay. For the same paragraph, can you write this one also? The element with the lower electronegativity, the element with the lower electronegativity is generally the central atom, central atom, central atom. But you can remember that theory, right? මෙමයි මේ theory ටික මතක තියාගන්න, but I'm sure you can clearly identify the central atom by looking at the iron and molecule. Okay, කිසිම අවුලක් නෑ, ඔයාලට බලා ගන්න පුළුවන්. එහෙම නේද? Okay, right. So right, now you can write the ions and molecules one by one, and then you can mark the central atom, right? Try to do that. Now, okay, right, right. අද ඔයගලන්ට මේ දවසේ කරනකොට surely I'm sure you will be able to draw the Lewis structure with yourself. Doesn't matter, right? Without confusing, without getting trouble. අනිවාර්යෙන් පුළුවන් අදින්න. So then I will move to the past papers also. Okay, surely, right? Surely next Wednesday and Friday, not this Wednesday, and next Wednesday and Friday will be the 2024 paper, right? Surely, I'm sure you will be able to draw the Lewis structure for the coming paper. Sure. Okay. Look that. අනිවාර්යෙන් ඔයගලන්ට මේක අදින්න පුළුවන්. හරි? Right? Right, I will give a challenge. Okay, my challenge කරනවා පුළුවන් අදින්න කියලා. Right? After you finish, you let me know when you finish that, right? Have you all finished? Did you mark the Lewis central ladder? Finish. Some people still didn't send me the message, your names and school. Can you send me that? Okay, right. Right. The first thing is you have to identify the central atom, and now I am going to draw the skeletal structure by placing the central atom. Okay, a very easy way, right? It is not a difficult task. Okay, but you have to identify the central atom, and then you can connect a surrounding atom by a single bond. Okay, if you was able to identify the central atom, then you can draw the skeletal structure without troubling like this. The central atom is oxygen. You can place other elements by connecting with a single bond like this. This is the skeletal structure because already you have identified the central atom. Okay, then CO2. What is the central atom of the CO2? C. Right, you can connect other atoms by one or single bond like this. What is that? NO2 minus, right? Don't get upset about the minus value, right? You can identify the central atom and you can draw the, you can place the other atoms by a single bond, single line like this. Okay. I will give in, I will getting ClO4 minus, Cl. What are the others? Of the 4 oxygen atom, you can place that oxygen atom as this. Right? You don't need to consider, you don't need to care about the shape, right? Shape, right? You don't need to care about that. You can draw the skeletal structure like this. Okay? Are you all clear? Are you all clear? Are you all clear? Okay, after you identify the central atom, you can place other atoms, other surrounding atoms by connecting with a single bond, with a single line. I think surely, are you all clear? Okay, okay, right, okay, right. Okay, now write this sentence. Right. It is important to consider the following factors, right? It is, write down this. It is important to consider the following factors. It is important to consider the following factors for molecules and ions with one central atom. Okay, one central atom means this is simple ions, right? Then I will give in multiple central atom, right? How to draw the Lewis structures for the multiple central atom. Okay, right. First thing you have to be consider the first one, right? If you miss the note, right? Yeah, can you repeat that sentence again? Right, sure. It is important to consider it is important to consider the following facts. It is important to consider the following facts. For molecules and ions, with one central atom, first thing you have to consider, the first one is identification of the if you miss the note, definitely I will send some pictures about regarding the today's lecture. Okay, and then I have a lecture recording. Okay, I will give it the recording to you. Okay, right? Don't get upset about that, and you can write the ඔයාලට මොකක්ද මිස් වුණා නම් මේකේ ඒ මිස් වෙච්ච තැන මගේ අර ලියාගෙන යන්න ප්‍රශ්නයක් නැහැ because I will provide the notes for every day. Okay, the first thing is identification of the central atom and surrounding atoms. Already we have identified identification of the central atom and surrounding. Sure. I will send the note of December. You mean now you want to see the note? Datang kalian tika datang. Biarkan note දාන්න කියලා කියන්නේ. Okay, sure. Right, I will send the note. Okay, so the first thing is identification of the central atom and the surrounding atom. The second one is no. Okay, right. Before we move to the second one, we have to draw the skeletal structure. Okay, identification of central atom and surrounding atom. And surrounding atom. To draw the skeletal structure, to draw the skeletal structure, place central atom and surrounding atom by connecting with a single line. Single line means this is a single bond. Okay, can you all try to draw the skeletal structure for these ions and molecules? Okay, are you all clear now? Clear, right? Now you can try to draw the skeletal structure for all those ions and molecules. I will give in more ions and molecules. Try to draw this one. Try to draw the skeletal structure for these ions. Right. After you finish, take a picture and send me the correct skeletal structures to where the parts are. Everybody should send me the picture. Right? Right, and when you draw the skeletal structure, please give some space between two ions, two species like this, right? When you draw the skeletal structure for the H2O, and don't draw the skeletal, then second skeletal structure near to that one, right? You can give some considerable space, right? And then you can draw the skeletal structure for the second one, right? Like this, right? Everybody should send me the uh, correct uh, skeletal structures to me. After finish, right, you send me your skeletal structures. Shehana, the okay. Yeah, good, good, very good. You don't need to consider about the shapes and other things, right? You can just put the surrounding atom, the right, correct, huh? Okay, good. Others, quickly send me that. Okay, good. The what's your name? Nimasha. Good, good. Shamaya. Yeah, very good. Others, others. They mean, yeah, you are correct. Yes. Others. Don't get more time because we have to do lots of work today. Okay, finish. Somebody still didn't. Okay, right. Okay. Right. NO2 minus. This is the scalar structure. NO3 minus. Right. NO2 plus. SO2 and SO3. This is the Lewis structure, scalar structure. Then CO32 minus COONO. SO3, SO42 minus SOOONO. SO32 minus SOONO. ClO4 minus OONO. ClO3 minus ClOONO. Right? It's not a hard thing. Then ClO2 PO4 3 minus and SF4 and SF2, right? Okay, right. These are the skeletal structures for ions, right? Everybody finished that? Clear that? Okay, right. Right. Let's move the second facts. Okay. The second thing to be considered is, okay, the second fact is, Pradhan, can you write this fact and sentence? Calculating the total number of electrons, I will explain. Calculating the total number of electrons for a given chemical formula, considering all electrons, okay, calculating the total number of electrons for a given chemical formula, considering all electrons in the valence shell, considering all electrons in the valence shell of each atom, okay, right? I won't repeat now. I won't repeat. Anybody? Calculating the total number of electrons for a given chemical formula, considering all electrons in the valence shell of each atom, okay. But this is not a difficult task, okay. Valence shell mean outermost cell, okay, right? You have to calculate the total number of valence shell electron. Valence shell electrons, the number of valence shell electrons are equal to the group number. Okay, can you tell me the group number of the element is in the element of hydrogen is in the periodic table? What is the group number? 1. What is the group number of carbon? 4. Okay, in our A-level syllabus, right, we are given the group number as 14. Not you have to consider that 14, right? You can consider the number as in your use in your O level. Okay, in your O level stage, you use the group number as 1, 2, 3, 4, 5, and 6, like that. No. Okay, what is the group number of oxygen? Oxygen. Quickly. Yeah. What is the group number of sulfur? Yeah. What is the group number of chlorine? Not 17, 70. Okay, that's why I clearly mentioned that not 17. Yeah, it is correct, 17, but you have to identify as 7. Okay, am I correct? Clear? 7, because it is the easiest way to get the number of valence shell electron of a specific atom. Okay, 7. And what is the group number of aluminium? Aluminium. Very good. Very good. Okay, now it's clear now? Okay, right. You have to consider the total number of valence shell electrons of the iron, right? How do you get that? Right, quickly you have to do that. Oxygen is in the sixth group. So 6 and 6, 12, and this is in the fifth group, right? 12 and this is for the NO2 minus, no? Okay. Total number of electron is 17. And when you are getting total number of electrons, if it is an iron, if it is a negative ion, you have to add one more electron. Okay, if it is an iron or if it is a negative ion, you have to add one more electron, which means if it is NO2 minus, this is NO2 minus, I think. NO2 minus. So N means fifth group, sixth group, and 12 and 17 and 18. Yeah, 6, 12, 12 and 17 and 18. 18. Okay. If it is a cation, if it is a positive ion, you have to substitute one electron from it. Okay, what එක electron අඩු කරන්න ඕන, ධන එකක් නම් එක electron එකතු කරන්න ඕන අර total valence shell electrons වලට minus එකක් නම්. හරිද? ඒ කියන්නේ ඒක right පාර කරන්න තියෙන valence electrons ටික එකතු කරන්න ඕන හැම කෙනාගේම. හරිද? මෙයා ඉන්න 6 වෙනි group එකේ. මෙයා ඉන්නේ 5 වෙනි group එකේ. එතකොට 6 නම් මෙයාගේ electrons 6යි. මෙයාගේ 6යි. මෙයාගේ 5යි. 6යි 6යි 12යි. 12යි 5යි 17යි, but it is an iron, it is a negative ion, so you have to add one more electron. 18. Clear? All of you? Clear? Clear? Quickly. Are you all clear? Okay. Right. This is, I think, NO3 minus. NO3 minus. Right. Can you tell me how many total valence shell electrons in the NO3 minus? Can you tell me quickly? Quickly. You have to do the work quickly because we have 24 and 6, 6, 6, 18. 18 plus 5, 23. 23 plus 1, 24. Are you all got? Clear? Everybody? Everybody are clear? 6, 6, 6 and 16, 18. 18 plus 5 mean 23. 23 plus 1 mean 24. Right. 24. Okay. 24. Can you all get the total number of valence shell electron for the each and every ions you have drawn in your book? Can you all come in quickly? Right, quickly. Right, this is, I think, NO2 plus. This is NO2 plus. Wait, look this. NO2 plus. Oxygen 6 and 6, 12. 12 plus 5 mean 17. But it is positive. You have to substitute one electron. 6, 6, 12. 12, 5, 7, 17. When you substitute one electron, it is 60. 60, right? I think you are clear. Right? Can you get the total number of electron? Right? I'll give in 5 minutes, right? Quickly. Finish. Finish. I will finish. Okay. Okay. Shall I move to the next fact? Okay. Okay. Then you can divide the total number of valence shell electron by 2 to get the pair of electron. Okay. You have to get the pair of electrons. Okay. To get the pair of electron, you can divide by 2, right? Can you quickly do that work also? Right? You can divide by 2 and get the answer, right? Right? Divided by 2 is 12. Divided by 2 is 8. Right? Like that, you can divide everyone's by 2. Finish. Okay, can you all divide by 2? Okay, finish. Right, first you have to draw the skeletal structure, then you can calculate the total number of valence shell electrons, and you can divide it by 2 to get a pair of electrons. Okay, right, I think, okay, finish, no? Yes, Pita, Himanshu, I finished. ഇവരത് Himanshu, yes, finish. Okay, right. Try to finish it all quickly. Okay, finish. I think you all have finished. Uh, Finish. Okay. Now, to this point, all have clear now. Finish. Yeah. Yes. Okay. Right. Let's move to the second and the next step. This is something important, right? Listen to me and be carefully. Right. Right. This point is very important, right? Attention, like to here. Right. Memai aganna. This is very important. And now you have got the pair of electron in that species or the molecule of the iron. You have got the pair of electron. Okay. For the single bond, for the single bond, you have to receive one pair. You have to receive one pair. Okay. This is this bond is formed by two electrons. So you have got the total number of electron pairs. You have got the total number of electron pairs 18. Okay. Can I get the some easy one? Okay. Right. I will draw the some right H2O. H2O. This is H2O. Right. H2O. And the total number of electrons are 8, 1 and 1, 10. You got the 10. Now you can divide it by 2. Pair of electrons are 5. Okay, already we received 2 electrons for one bond. 1 electron pair for one bond. Okay, therefore not 8, no, sorry. 6 and 1, 1 and 2 and totals are 8. 8 divided by 2 means 4. Correct? Correct. Already you have received one pair for one bond. Okay? Therefore, මෙහෙමයි ඔයගොල්ලෝ මේ එක බොන්ඩ් එකට එක පෙයාර් එකක් වෙන් කරන්න. එතකොට මේ බොන්ඩ් එකට එක පෙයාර් එකයි මේ බොන්ඩ් එකට තව පෙයාර් එකයි. පෙයාර්ස් දෙකක් වෙන් කරා. How many pairs were remaining? How many pairs were remaining? 2. Okay? You have to place that pair of electrons to the most electronegative atom. Got it? You have to place that remaining pair of electrons to the most electronegative atom. First you have to consider the surrounding atoms, then you can consider the central atoms. Okay? Clear? I'll repeat. You have to get the remaining pairs. Okay? Then you can put that remaining pairs on the element, on the atoms. First you have to consider the most electronegative atoms. මුලින්ම සලකන්න ඕන වැඩිම electronegativity එක තියෙන කෙනා, but surrounding, but ඒගොල්ලන්ගේ නැත්තම් you can consider the central atoms. මෙහෙම දෙකක් ඉතුරුයි. hydrogen. Okay? hydrogen ගත්තාම මෙහෙම අපි කරන්නේ. තව එකක්. Right? hydrogen ගත්තාම hydrogen වල තියෙන කොහොමත් only one electrons. You should have to satisfy the octet rule. Okay, I need to explain the octet rule. Okay, then I will give the note in another lesson. Octet rule එක හොඳට අහගන්න. You have to satisfy the octet rule. Octet rule means you can put the electron until it reaches to octet. Octet means electron, 8 number of electrons. Okay? Clear? ඔයාට මේ තියෙන remaining pairs ටික දාන්න පුළුවන් until it reaches to octet rule. Clear? Right? Clear? Right. Okay. Hydrogen only one electron is there and it is in the first energy level, only two electron can be occupied, only two, right? Already it was there, right? Hydrogen ගත්ත මෙයා ඉන්නේ first energy level එකේ. First energy level එකේ you can use maximum of two electrons. Okay, already it is in that bond. Right. මේකෙත් එහෙමයි. The remaining two bonds are the two pairs are there, right? You can put that pair of electron until it reach to octet rule. Octet rule mean what do you mean by octet rule? Can you tell me that? What do you mean by octet rule? Octet means total number of outer cell electron is 8. It should be satisfied 8 number of electrons. That is the octet rule. Don't think too much about that. That is the octet rule. Okay. Now I will place that pair of electrons. Already two electrons, total of 4 electrons are there. Okay. Until this reach to octet rule, you can use another 4, 5, 6, 7 and 8. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Complete. Okay. Finish. Okay. I will give the note and I will draw in one by one. Okay. Can you write this one? Can you write this one? Right. Remove one electron pair at a time from the electron pairs involved in the bonds. Remove one electron pair at a time from the electron pairs involved in the bonds. Involved in the bond. Oh yeah, you can remove pair of electron to the bond. Okay. Right. Then next sentence. Take remaining electron pairs. Take remaining electron pairs and place on the atom. Place on the atom until it reached to octet rule. Place remaining electron pair on the atom until it reached to octet rule. First we are considering surrounding atoms and most electronegative atom when when place pair of electron, when place pair of electron, okay, when place pair of electron, okay, right, clear නේද? අර ඉතුරු ටික අරගෙන අපි ඉස්සෙල්ලාම surrounding atoms වල දාන්න ඕන මොනවා කරගෙනවද until it reach to octet rule, but you have to consider first you have to consider the surrounding atom and also what's them most electronegative atom. Okay, right. Okay, I will erase all those things and I will take one by one. නැත්නම් අවුල් ජාලයක් වගේ නේ පිස්සන් කොටුවක් වගේ නේ පිස්සන් කොටුවක් වගේ දී පිස්සන් කොටුවක් හරි right okay right I will take carbon dioxide. First I choose the central atom and I have drawn the what's that skeletal structure. Now I got the total number of valence shell electron 4, 6 and 6 12, 12 and 4 16, right? I got a pair of them 8. Okay, I have received 2 pairs for these two, right? 2 pairs. Okay, can you finish? Okay, clear 8 pairs are there. I have received 1 and 2. Okay, 2 pairs for these 2 points. Then remaining 2, the remaining is 6. 6 pairs are there. Okay, you have to place that pair of electron. First you have to consider surrounding atom and until it reaches to what's that octet rule. Okay, already 2 electrons are there. Are you okay? Already 2 electrons are there. Why? 1 bond mean 2 electron. Are you all clear? Everybody? Are you all clear? Are you all clear? Clear now? Right? Already 2 electrons are there. Okay. Right. 2, 3, 4, 5, 6, 7, 8. 7, 9. Now finish because it has reached octet rule. Octet means 8. 1, 2, 3, 4, 5, 6, 7 and 8. Right? Then you can use another surrounding atom. We have used 3 pairs. Another 3 pairs are there. 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, all the pairs we have used. Clear? Right. Then NO2 minus. Okay, first you have to identify the central atom, surrounding atom. Right, total 5, 6 and 6 12. 12 plus 5 means 17 plus 18. And you can pair that 9, right? You have to receive 2 pairs for these 2 and remaining 7. Okay, first we have to consider which atom you have to consider. First which atom you have to consider? Surrounding your central atom. Can you tell me that? Surrounding your central atom. Surrounding your central atom. Surrounding. Okay, right. Already we have 2 electrons. Until it reaches to octet, we use 6 electrons. 3, 4, 5, 6, 7, 8. Then you have to move 3, 4, 5, 6, 7, 8. Already we have used 1, 2, 3, 4, 5, 6 pairs. අපි pairs 6ක් දෙන්න පාවිච්චි කළා. ඔක්කොම 7ක් තියෙනවා. Right? 7ක් තියෙනවනේ ළමයි. ඔක්කොම 7ක් තියෙනවා. Right? Remaining 1 pair. you can use for this one, right? Like this. Clear? Are you happy? All are clear? All are clear? Okay. Right. Which one? SO2? Right, SO2. Sulfur means 6. 6 and 6, 12 and 18. First you need to get central atom and surrounding atom. Right, you can divide by 2 and 9. 9. Right, only 2 electrons are there. To get octet rule, another 6 electron is needed. 1, 2, 3, 4, 5, 6. Then don't use next atom is not another sulfur, because remaining one surrounding atom is there. It is the most electronegative atom. Right? 1, 2, 3, 4, 5, 6. Right? Already we have used how many? 1, 2, 3 pair. 1, 2, 3 pair. 6 pairs we use. And remaining 3 pairs are there. 3 pairs. 1, 2, 3, 4. No, 3 pairs. Clear? Everybody? Everybody? Okay, right. Let's move that to the notes. Okay, can you write this sentence? Okay. Right, can you write this one? A bond is denoted by a pair of dots. Bond is denoted by a pair of dots. Between the central atom and a sir, so 2 you have withdrawn, sir. There are 11 pairs. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs now. Pata? Oh, very sorry. I got wrong. Ambo, you have to receive 2 pairs for that, no? I'm sorry. Okay. Okay. Yeah. This is the correct one. Now is correct, no? Now is correct, no? Okay. Okay. Sorry. Okay. A bond is denoted by a pair of dots between the central atom and the surrounding atom. Each surrounding atom is connected to the central atom with at least one bond. Yes, Dimasha? Okay. So can you all try to draw that by placing the electron? Pata? You don't need to consider the previous ions and molecule. Can you try to draw the ions I am giving? Okay, CO2 first then NO2 try to do that. Okay. මේ ටික එන්න පටන් ගමු එන්න. මම සෙන්ටෙන්ස් කලින් දීලා තියෙන්නේ. එහෙනම් දැන් මේක පොඩ්ඩක් පටන් ගන්න අඳින්න. මාත් එක පිටව අඳිමු. මාත් එක අඳ පිටිපස්සේ. ඉස්සර මේක අඳ ගන්න. අපි ඊට පස්සේ බලමු අර කලින් දීපු එක. අද ඔයගලන්ට පුළුවන් කරලා දෙනවා නැත්තම්. Finish. Okay, try to do that work with me for the SO3. SO3. Have you finished these three? මේ ටික ඉවර කරාද ඔයගොල්ලෝ? මේ තුන ඉවර කරාද? මම පොඩ්ඩක් කියන්න මේ තුන ඉවරද කියලා? This one, these three. Okay, right. Try to do with me for the SO3. Okay, SO3. I will give in. So can you put two bond between? Okay. No. Wait. I will do it one by one. Okay, right? Don't put two bonds and double bonds. Okay, I will give in one by one. Okay. Right. SO3. I will give 2 minutes to complete. So can you all send me a picture? So can you all send me a picture? Everybody? Oshadi, good. Others, can you send me a picture? Shama, good. Correct. Others? Chanul, Dheerad, Chanul, Shanaya, Shanaya, good, correct. Nimasha, good, correct. Others, Chanul, Bimaya, good. Okay, okay. With our sulfur means 6. 6 into 3 mean 18. 18 mean 24. Okay, sulfur, oxygen, oxygen, oxygen. Okay, yeah, then you can divide it by 2. 12. 12. Oh. Oh, මම දැන් ක්ලාස් එකේ නිකන් ආන්සර් කරත් වගේ එක්සෑම් එක නිසා මේ වැඩේ නම් හොඳට දෙන්න ඕනේ. Right. 12. You have to receive the 3 pairs for that, right? 3, 9. Okay, 9 mean to until reach to the octet plural, 1 pair is there. 2, 3, 4, 5, 6, 7. No, 8, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. I think all every 9 pairs we have used. 3, 6, and 9. Okay. Let's finish the Lewis structure for these 4. Then we will move the next new ones. හරිද? මුලින්ම මේක ඔක්කොම ඉවර කරලා. හරි. ඒතකොට ලේසි. ඒතකොට බෝඩ් එක මහන්න පුළුවන් මට. හරිනේ මේ වෙනම ඔක්කොම. හරි. ඊගාට කරන්නේ මේකයි. Next you have to give the proper stable bonds between two atoms. Stable, proper bonds between two atoms. Okay. I will give in the stable number of bonds. How many stable number of bonds for specific atom, okay, should be there. මෙහෙමයි වෙන්නේ. දැන් ඔය හැම atom එකකම තියෙනවනේ, right? There are specific number of bonds. Okay, a specific number of stable bonds පුතා. හැමෝටම තියෙනවා stable bonds ටිකක්. මම ඒක table එක දෙන්නම්. Okay, මෙන්න මෙහෙමයි වෙන්නේ. You can use this table. Okay, මොකද දන්නවද? මට බකන්න මේක මේ, right? This is a group number. Can you write this one? Next step. Can you write? Okay, right. Wait, 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 just a moment. Wait. So the next step is not the not use the table, right? Erase that one. Okay, right. Next step is you have to put the formal charge. Formal charge. Okay, formal charge. Okay, I will give in the formula to get the formal charge of each and every atom. Okay, මෙහෙමයි අපිට දෙන මේක formal charge එක කියලා එකක් ගන්න. Okay, ඒ next step එකේ අපි යන්නේ formal charge එක ගන්න. Right, formal charge. Wait to get the formal charge. Wait, okay. Just I need 1 minute, right? Which step you should have to follow the formal charge or the bonding? Wait. Okay. I need just 1 minute. Just 1 minute. Yes, you should have to get the formal charge. Can you write this sentence? Okay. In order to minimize the formal charge on the is the total electron around the atom say to the nitrogen. Okay, right. Can you write this one? After distribution or after distributing, yeah, right. Write this one. After distributing all the electron pairs, after distributing all the electron pairs or the electron pairs, the number of electrons on each atom after distributing all the electron pairs, the number of electrons on each atom, the number of electron on each atom should be compared with the number of electrons in the non-bonded state of the atom, right? Non-bonded state of the atom, which means free atom. Within bracket, can write that Sure. Nimansha, sure. After distributing all the electron pairs, the number of electrons on each atom should be compared with the number of electrons in the non-bonded state of the atom, which means free atom, to assign the formal charge and then check completion of the octet. Of the octet. In the case of a bond, one electron is counted for each atom. In the case of a bond, one electron is counted for each atom. And if lone pairs are present, I will explain each and everything, okay? Lone pairs are present. Both electrons are counted to the particular atom. Both electrons are counted to the particular atom. Priority is given for completion of the octet. Priority is given for completion of the octet. Okay, right? Because sometime I use this step after the giving the double and triple bond. Sometime I will place formal charge. That's why I was think that which step is first. අපි මොකද්ද මුලදී ගන්න කල්පනා කරේ මම ඒකයි. සමහර ලාවට මම ක්‍රම දෙකක් තියෙනවා මම කිව්වේ අර මම මුලදීම කිව්වනේ ක්‍රම දෙකක් තියෙනවා කියලා. ඒ ක්‍රම දෙකේදී මම සමහර ලාවට ගන්නවා අර ඩබල් බොන්ඩ් ට්‍රිපල් බොන්ඩ් එක මුලින් දාලා පස්සේ charge දාන method එකක් මම ගාව තුන එකක් මම කියලා දෙනවා. Okay? තව method එකක් තියෙනවා. මේ method එක ඒ කියන්නේ charge එක දාලා ඊට පස්සේ double bond triple bond කරන method එක. මම ඒක කල්පනා කරේ මම දැන් මේ වෙලාවේ කරන්නේ මොන method එකද කියලා. හරිද? Okay. මෙහෙමයි කරන්න තියෙන්නේ. Okay? අමාරු නෑ. Right. Now you can calculate the total number of electron in valence shell in their free state. Then මට කියන්න how many number of electrons was there in oxygen, there's the valence shell. යාගේ free state එක කොච්චර තිබ්බද? 6යි නේද? 6යි. Now 1 2 3 4 5 6 and 7, right? This bond is formed by one electron from this oxygen and one electron from this one. Okay, therefore now we have placed 7 electrons for oxygen. Why? 1 2 3 4 5 6 and 7, right? Out of 2 electrons in the bond, one is of oxygen, one is of carbon. Got it? Clear? So now we have placed extra one electron on that oxygen. Then you have to place one minus charge because already we have used one extra electron minus. Okay, 1, 2, 3, 4, 5, 6, and 7. 1 minus. Are you all clear that step? Are you all clear? Okay. Now a carbon, uh, four valence shell electron were there. Now it have two, 1 and 2. Therefore, 2 electrons were lost. 2 electrons were lost. So you have to use 2 plus. Instead of that, you have to use 2 plus. Got it? Are you all clear? Are you all clear? Okay, let's move this one. Oxygen, 6 electron were there. Now 1, 2, 3, 4, 5, 6, and 7. You can use minus. 1, 2, 3, 4, 5, and 6, and 7. You can use minus 1. 5 electron was there. Were there. 1, 2, 3, 4. Therefore 1 plus charge. Everybody? Everybody? Others? Nimasha? Shamay? Okay. Right. Let's put the SO2. Okay. 1, 2, 3, 4, 5, 6, and 7. You have to use minus 1. Sulfur also 6 electrons were there. Now 1, 2, 3, and 4. Therefore, 2 less, 2 plus, and 1 minus. Got it? Are you all clear? Clear? Right. Can you put the charge for it? Try padanga. This is I think we were close to finish the Lewis structure. I think I need another few minutes to finish that. Quickly do that. SO3, 1, 2, 3, 4, 5, 6, and 7, 1 minus. 1, 2, 3, 4, 5, 6, and 7, 1 minus, and 1 minus. Total of 6 electrons were there. Now it is 1, 2, and 3. Therefore 3 plus. Clear? Can you write this one also? CO3 2 minus. C, O, O and O, O and O, and 4, 18, 22, and 24. 24 divided by 2 means 12. You have received 3 pairs for it. So 9. So 9. 1, 2, 3, 4, 5, 6 to get a octet. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Therefore 1, 2, 3, 4, 5, 6, and 7. 1 minus. 1 minus, and 1 minus. Okay. 4 electrons were there. So now 1, 2, 3, there are 4 plus. Got it? Everybody clear? Everybody clear? Everybody is clear? Are you all clear? Okay, right. Let's move to the last step of it. Okay? දැන් මම යන්නේ මේක අන්තිමේට ඉඩමදි පොඩ්ඩක්. ඉඩමදි කේස් එක මම සමහර ටිකක් මේක මකන්නම්. පස්සේ ආය අඳින්න. හරි? ඔය ඉඩමදි. මම මේක පොඩ්ඩක් මකන්නම්. Right. Now we have to use stable bonds between two atoms. Okay, I will give in the table. Okay, I will give the table. This is group number. This is element. Element and stable bond. Stable bond. Hari, amaru right very important things. Okay, okay, right. Group one, every elements. Okay, hydrogen, lithium, sodium, every one bond is there. The second group, beryllium, magnesium, right? 2 bonds are there. Third one between 13, boron, aluminium, right? Gallium, indium, gallium, 3 bonds are there. Fourth one between 14, carbon, silicon, germanium, tin lead, 4 bonds should be there. And fifth group between 15, nitrogen should have only 3 bonds. Phosphorus and arsenic can be 3 and 5. Right? Right. I need to give the table. Okay. Right. Let's do the table. Right? Write this sentence. Okay. Okay. After distributing all the charge and electron pairs on the, or as of distributing all the electron and charge on the structure, try to place stable bonds between two atoms. Try to place stable bonds between two atoms. Okay. Can you all write this, draw this table? පටන් ගන්න කලින් පොඩි වෙලාවක් ඕන වෙන්නේ කියලා. I have another method, okay? Right, then after I will give another method. Okay, මම කිව්වට මේ bonds ටික දාලා charge දානවා කියලා. ඒ method එකත් මම දෙන්නම්. හරිද? ඒකත් මම දෙන්නම්. මේකත් අපි කරලා ඉවරනවා. ඔයාලට පුළුවන් ඕන method එකක් පාවිච්චි කරන්න. So if you don't mind, can I know the finishing? Right, sure. I will just I need another 10 minutes. Sure. Okay, this is the last step. This is the last step. Then I will finish, and then next time I will give that second method also. Then we can draw Lewis structures for any ions and any molecules. No, it's okay. It's okay. But last time I think I have told you I need 2.5 hours for it. Come on, man. Right. Finish. Then 6 and 16 group. Oxygen should be total number of 2. Sulfur, selenium, and others there can be 2, 4, and 6. 7 or 17. Fluorine should be only 1. Chlorine, bromine, and iodine 1, 3, 5, 7. Right? Right, you can close the table. Okay, that is the last step. Then I will complete the Lewis structure. Right? Sorry for I had to taken your thing almost 15 minutes. Like it just I need 5 minutes. මේක අර මගින් නැවතුත් වැඩක් නෑ. ඒකයි ප්‍රශ්නේ තියෙන්නේ. හරිද? මම ඒක මගින් නැවතුත් වැඩේ කරන් ගියේ. නැත්නම් අර මගින් අර කෑල් වගේ ඉතුරුත් next time එකේ අපිට මේක connect කරන්න අමාරු වෙනවා. Right? That's why I needed to complete that. Have you finished? Have you finished? Can I reach that table? Sure. Can I use this one? Right? Okay. Oh, no, wait. Right. Now, the last step is you have to give stable bonds like this. Now, the oxygen should have 2 bonds. Therefore, you can give that 1 pair toward the carbon to get double bond. මේ pair එක මෙතෙන්ට දෙන්න to complete the double bond between oxygen. Okay? So therefore, මේ pair එකයි මේ plus එකයි cancel වෙනවා. මෙන්න මේ pair එකයි මේ plus එකකුයි cancel වෙනවා ඒකට. Right? You can cancel this 1 plus and 1 pair for it, and you can use this pair toward the carbon to complete double bond. Then you can cancel 1 pair and 1 plus charge for it. Okay, now rearrange that one like this. Rearrange like this. Double bond, carbon, double bond, carbon. 2 pairs were remaining. 2 pairs were remaining. No plus charge, no minus charge. This is the complete diagram. This is the complete diagram. Okay. Now this one, right? Oxygen should have, this is NO2 minus. Oxygen should have double bond. You can give that pair toward the nitrogen. You can cancel minus and plus for it, and N, O and O, two pairs were remaining, one pair and one minus, because total of three bonds should be there. හරිද? nitrogen වල තුනයි දෙන්න බලන්න. දැන් තුනක් තියෙනවා. right? මෙන්න මේක මෙහෙම තිබ්බා. දැන් අපි ඒක වෙනස් කරන්න යන්නේ නැහැ. මොකද ඒක වෙනස් කරන්න ගියොත් මේක තුනක් ඇති වෙනවා. right? මේක දැන් ගත්තම we have used three pairs, right? මේක electron එකක් වැඩි නිසා minus එකක් තියෙනවා. right? Right, can you all complete this one? Right? And SO2, SO and O, total of 18 divided by 2 mean 9. You can substitute 2 for it, 7. 7 mean 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 remaining 1, minus 1, minus 1, that because of we have used extra 1 electron, 1, then මේක තියෙනවා 1 2 plus 2 plus, therefore you can use this arrow for this one to get double bond, this pair for this one to double bond, therefore O double bond, S double bond, 2 pairs were remaining, 2 pairs were remaining, 1 pairs for on oxygen. Got it? Got it? Last molecule that I'm going to draw the Lewis structure, then I will finish the class today. Okay, SO3. SO, O and O. Sulfur made 24 divided by 2, 12. 12 mean you have to receive 3 for the bonds, 9 were remaining. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 minus, 1 minus, 1 minus. මෙහා ගත්තම 6ක් තිබුණා, දැන් තියෙන 1, 2, 3. Therefore 3 plus. You have to use this pair for this one to get double bond, this pair for this one to double bond, this one to double bond. So you can rearrange that molecule as this: double bond, double bond, double bond. 2 pairs were remaining, 2 pairs were remaining, 2 pairs were remaining. Hola. Hola. Everybody is clear? How do you feel that? Are you all clear? So then I have another method. මම කිව්වේ කනේ මම සමහර වෙලාවට bonds ටික දාලා formal charge mark කරනවා. formal charge දාලා bonds mark කරනවා. මේකේ formal charge දාලා bonds mark කරන එක ටිකක් lazy අනිත් method එක. Right? Something is that. Okay? The next time I will give the second method, and we are drawing so many Lewis structures in next time, right? Are you all clear? Are you all clear? How do you feel that? It's clear? Don't left. How do you feel that? Are you all clear? Right. Everybody should have to put a message to the group, and how did you feel this class on today? හැමෝම පොඩි message එකක් දාලා යන්න group එකට අද class එකට ආවද සහ කොහොමද මේක feel උනේ කියලා පොඩි message එකක් අනිවාර්යයෙන්ම දාන්න. එතකොට next time I will give another method to draw the Lewis structure, and I will draw so many Lewis structures, and I will try to do the past papers also. Sorry, I had to go taken another, I think, 24 minutes from you. So, right, good night and see you in next time. Right, next Sunday, 8 to 10, we will draw so many Lewis structures. Okay, good night. All of them should try to put the message, okay, to the group.